Dear learners, welcome to our NPTEL course on Science Communication, Research Productivity and Data Analytics using open source software. Now we are going to cover Zipf's law. Zipf's law basically is an empirical law which describes the distribution of frequencies element in a dataset. Zipf's law deals basically the distribution of frequency of element in a dataset. If you see all around us, then we find that most of the things are in average. For example, if we want to find out the height of the student of a particular class, we get almost the average height. In some cases it would be, a student would be very tall, another student would be very short, but usually we get the average height of the student. But this does not happen in case of language. So basically when we talk about Zipf's law, so Zipf's law is the distribution of frequency of elements in a data set, and it describes the frequency distribution of words in a large text corpus. For example, if you have a large text corpus, a corpus having a million or billion of words, for example, let us see Wikipedia or any other, let us see archive of any particular newspaper X. And if you want to find out which is the word which occurred the maximum number of time, which is the word which occurred the least number of time, here we have the use of Zipf's law. Basically, Zipf's law describes the frequency distribution of word in a large text corpus, and Zipf's law is named after linguist George Kingley Zipf, who observed that a frequency of a word in a text is inversely proportional to its rank. What Zipf observed, that the frequency of a word is inversely proportional to the rank. That means the word of a large corpus which rank is first, and the word which in that particular corpus having rank second, there is relationship between the rank and frequency, and the frequency of a word in a text is inversely proportional to the rank. That means the rank multiplied by frequency in any given corpus is a constant. The frequency of the word inversely proportional to its frequency rank. Based on his observation, he found that, or based on the observation of Zipf, we can say that 20% of the word filled 80% of the corpus. Means some words used very frequently in a corpus as compared to another word. Some words used very frequently, some words used less frequently. And the words which are used frequently are short, and the rare words, that means the words which are used less frequently, are longer. Many words in a corpus, in a particular language corpus, used very rarely, and this type of words are known as hapax legomena, which singular is hapax legomenon. That means the word which used very rarely is hapax legomena. The word that used only once is basically the Hapax legomena, and this is the famous example of Hapax legomena from the work of Shakespeare, and this particular word has used only once in the literature of Shakespeare as per the available record. Here I have taken an example from Wikipedia, and the source I have already mentioned here. On x-axis, this one is this axis, this is x-axis, this is frequency rank, the rank of the word, how many times, how, what is their rank in Wikipedia, and this y-axis is basically the frequency occurrence, how many times of the particular word is occurring in Wikipedia. And we found that the study found that 100 most frequent word from Wikipedia was taken and the graph was drawn. This is the shape of the graph. In that it was found that the word "the", which was at number 1, which used approximately 5 million times. The word which was at rank 14, used 3,60,000 times, while the word being, which was at the rank 100, used 50,000 times. When we multiply the rank to the number of times the word is being used, that means 1 multiplied by 5 million, that is 50 lakhs, is 50 lakhs. When we multiply the rank of the word with the number of time it appeared in Wikipedia, like in this case, the word having rank 1, the, which appeared 5 million or 50 lakhs time in Wikipedia. If we are multiplying these two, we are getting 50 lakhs. Similarly, if we are multiplying rank 14 with 3 lakhs for 60,000, we are getting 50 lakhs 40,000, and the word which appears at the 100th place, that means being 50,000 time, 100 multiplied by 50,000, we are getting 50 lakhs. What we are observing here, they are almost constant. This particular quantity, this particular 50 lakhs 4,000, this is 50 lakhs, they are constant. That means when we are multiplying the rank with frequency in a given corpus, we are getting the same result, and that's what Zipf's law is. Zipf says the most frequent words occur approximately twice as often as the second most frequent word, 3 times as often as the third most frequent word, and so on. He said that the most frequent word occur approximately twice as compared to the second most frequent word. Similarly, the first most frequent word would occur approximately 3 times as compared to the third most frequent word, and so on. means the product of rank and frequency would almost always be constant. This is the general equation of Zipf's law, in which frequency is equal to C upon Rs. We have already seen, where Fr is the frequency of the element of rank R, C is a constant, and S is a parameter that typically falls in the range of 1 and 2. We understood Zipf's law. Zipf's law is basically the law which talks about the occurrence of word in a given corpus of words, and it says that some words occur quite frequently and some other words occur very less number of times. What are the different applications of Zipf's law? Zipf's law having various applications. The most important application of Zipf's law is in the field of linguistics. Zipf observed that some words like the and is appears very frequently. Zipf observed that some words like the and is appears very frequently, while there are some very less common words like ephemeral, which use very less number of times. In economics, there is application of Zipf's law. We see that most of the wealth of a country is concentrated to a very few number of people. The distribution of income, we can say that means a smaller proportion of population having larger distribution of income. It is basically the application of Zipf's law. We can find that in a particular society of the wealth is concentrated to a very few. Zipf's law can also be applied in city size distribution. For example, major cities have very large population, while a smaller cities and town having very less population. There is distribution of population, and that population is unevenly distributed in cities. Zipf's law can also be used in information retrieval. In information retrieval, the common search terms are used frequently, while more specific or niche queries are less common. While designing any information and retrieval system, we should keep in mind that the common search term should be used more as compared to any niche term or any new term. In case of biology, we see the application of Zipf's law. We see that few species are highly abundant in certain area, while majority of the species are less common. So this is basically the we can see here also the application of Zipf's law. Zipf's law is also be applicable in internet and social networking. We see that on social media platform, a few accounts or posts often garner a very large number of likes as compared to those which very less number of likes. What the Jeff said, a few words having the more number of occurrence as compared to some words having the less number of occurrence. Same thing happens here also in case of the internet and social network. Some of the posting will have the larger number of audience which popularity is more as compared to those posting which popularity is less. Zipf's law is also used in scientific citation. Some articles which get very large number of citation, very good citation. Some of the article get less citation. So that here also there is an application of Zipf's law. Zipf's law is also used in finances, like we often see that the share of some financial institutions companies jump very high, perform very high as compared to the share of some other companies and institutions. Zipf law can also be used in music industry, like we have seen that some of the songs are very much popular as compared to songs which are not very much popular, less popular. Traffic flow, we see that in some area in metros or in cities, the traffic is very high. In some area, the traffic is sparse, low. That's is basically the application of Gibbs law. Now, when we see as the application of Gibbs law in context of designing information retrieval system, then it's very important to see how Gibbs law can be applied in the designing of good information storage and retrieval system. The search engine follow Gibbs law, and some of the common words which are less informative, like as, though, and in, these are not uh, in their search paradigm. They are in the high frequency, and the information retrieval algorithm use basically the technique TF-IDF, that means the term frequency inverse document frequency, to give less weight to highly frequent terms. TF-IDF is basically giving the less weight to highly frequently used term, and by using Gibbs law, those words which use maximum number of time but having less relevance can have less weightage while giving the search result. Gibbs law, in case of designing of good information retrieval system, can be used for the query expansion, because we see that designing a good query is very much important to get good result. With the help of Gibbs law, we can find out which word should be used in our query strategy, in our search string, to get the maximum number of relevant result. Gibbs law, in case of information retrieval system, can be used for stop word removal. There are various small words. There are various set of words which are dominated in the language, which use very frequently, and but these words are not relevant in the context of searching. By that way, Gibbs, using the Gibbs law or information retrieval system, can put those words under the stop word list, and by that way we will get more relevant result by putting our queries. In context of information retrieval system, Gibbs law can be used for the indexing optimization, because the search result is based on the backend index. The backend index uh, of an information retrieval system can be such a way that those words which are not relevant should be stopped, should not be the part of the index, and by that way we'll get the maximum relevant result. Zipf's law in case of information and retrieval system can be used for the ranking algorithm also. Zipf's law in the context of information retrieval system can be used for the ranking algorithm, because a system, information retrieval system, can put the ranking of the terms, and based on the ranking the relevant result can be obtained by the users. This can be also used for the user query suggestion, because user can suggest the query based on the different words which can be used for retrieval of the result. And this law can be used for optimizing document retrieval because with the help of Zipf's law, the system algorithm can prioritize document containing less common term and having higher discriminative power, potentially leading to more accurate and contextually relevant result. In case of document retrieval, with the help of Zipf's law, the system can prioritize which documents should be delivered, which documents should be seen by the user while putting the ranking term, and by that way the user can get the relevant result. Similarly, Zipf's law can be used for the dynamic query expansion. Query can be expanded and the relevant result can be derived using Zipf's law. Feedback can be provided based on the result what we obtain, what a user obtain, and the can system can study the feedback, and based on the feedback whatever the system has taken, a more reverse system can be developed, the system can be improved, and more relevant result can be shown by the system. Now we have seen the different applications of Zipf's law. We studied the application of Zipf's law in detail, in particularly in context of information retrieval system. There are some limitations of Zipf's law. Zipf's law is basically observational nature. It is more of a statistical pattern rather than a fundamental law of nature. In the example, we have seen that Zipf's law is basically a law which gives that there is certain pattern in the occurrence of word in a given language corpus, and that varies from one corpus to another corpus. That means Zipf's law is not the law which is law of nature. This is not the law which is universally applicable because of the different region, because of the language is dynamic. There are various other aspects which are included in the development of language, not only the words. Hence, we can say that Zipf's law is basically a statistical analysis pattern, showing the statistical analysis pattern rather than the law of nature. Zipf's law is very much data sensitive. Different set of data exhibit variation in the extent to which they confront the law. We can take the different set of data and we apply Zipf's law. We find that there is variation we take the different set of data, we take the different data corpus, and we apply Zipf's law, we find that there is a variation in in the result what we get. That means is very much sensitive to data. It's a data, there is a data sensitivity. It's Zipf's law is sensitive to data. Zipf's law is also a scale dependency. They may not hold uniformly across different scales. Its applicability can diminish when considering less common words and when examining a smaller subset of the language corpus. Here, Zipf's law is scale dependent. Zipf's law, if you are taking a subset of data, then we find some error in Zipf's law. Another limitation of Zipf's law is lack of causality. It provides a statistical pattern but does not provide insight into underlying cause of the observed distribution. You see, when Zipf studied the corpus and he found a relationship between the rank of the word occurrence and the frequency, they occur is constant. But why this happens? There was no explanation. Didn't get any. There was no explanation for the statistical pattern which a particular language corpus follows. It does not explain why certain words or elements follow this distribution, leaving room for interpretation or hypothesis. You see, a universal law or the law of nature is such a way that it can be universally applicable in any context. But here, in case of Zipf's law, this is not the case, and there are certain limitations, and this law does not explain why some of the words follow this particular distribution in the language corpus. Another limitation of Zipf's law is a complexity of language. You see, the language is quite complex. The development of language is a dynamic process. The language system is a quite dynamic system. Hence, a single mathematical or a single statistical formula which was suggested by Zipf cannot be applied to the language model because of its complex nature, and that is one of the limitations. There is variability across the languages, different language having different pattern, they having the challenging of idea of universal linguistic law. You see, different language having a different pattern, different language having their different development criteria. Hence, there can't be a single law which can universally be applied on the different language. So that is one of the limitation here. Is a limited predictive power. Zipf's law provides a statistical description of the word frequency. It may have limited predictive power in certain applications. Predicting the occurrence of a specific word or event based solely on Zipf's law might not be highly accurate, because we have already seen that Zipf's law having the limitations, and hence predicting the result solely based on the Zipf's law wouldn't be good. It won't give us the correct result or correct figure. Zipf's law overemphasized on the rank because Zipf did he took the rank and the frequency of occurrence. So this law is basically overemphasizing on the rank and neglecting the other language structure and usage. That is another limitation of Zipf's law. Thank you, learners, and I duly acknowledge the sources, scholars, and website content provider, which content and material I have used in my presentation. Thank you, and for any query, you can contact me at my email address as vk@library.iitd.ac.in. Thanks for your patience hearing. Thank you.